Okay, so we are done with some FLSM examples in our previous section, and also we have seen some slash value, how it goes. Now coming back to the major part, VLSM, which is generally used to design the networks. Now VLSM is a method of dividing networks into variable sizes, may be equal, may not be equal. It depends. Like take an example, I got 4 different branch offices. And in one branch office, I got a requirement of 100 devices. Probably I have some users, 100 users. And in another branch office, I just have only 20 users. In another branch office, I got some 40 hosts or 40 users. And in another branch office, I just got only 10 users. So if I go with some FLSM, so normally in this scenario, we will never go with default networks. If I use default networks, I have to use 192.168.1 network here. 192.168.2 network here, 3 network, 4 network, which means out of 256 I'm just using only 10. So we don't go with default networks because there is a lot of wastage. So instead of that, the one option is we can go with the default network sizes, which is something I never want to do that because there's a huge wastage of that, of the addresses. So the next I can go with something called FLSM, where we can divide all the networks with equal sizes. So the possible size, I can use 128 here, 128 here, 128 here, 128 here. So in case of FLSM, what we are doing is we are dividing the requirement. So here the requirement is, what's the requirement? Requirement is 100 in one department and 40 in another department, 20 and then 10. So if I'm using FLSM, I'm going to divide them in 128 size. And if you divide everything in equal sizes, we call this as FLSM. But in case of VLSM, what we do is we divide to the nearest possible size. So which means 100, the nearest possible size, I go with 128. And for the next one, I go with 64 is the next nearest possible size. And 20, the nearest possible size is 2 to the power of 532. And the 10, the nearest possible size is 16. Now this is the major difference between FLSM and VLSM. In FLSM, we divide all the network size equally. Just like, so your kitchen, your bathroom, bedroom, everything is same sizes. So generally the classrooms of any organizations, so all will be on the same size, which is something not recommended. So we may have a different requirements here. So in different departments. So we can have a variable sizes. The sizes may be same, may not be same. I'm not saying always it will be different. It may be same, may not be same, where we are efficiently utilizing the addresses. Like in case of FLSM, 128, I got around 512 addresses required, a size of network with 512. Here I can just use around 200 plus addresses. So VLSM is a method which is going to, which will help you to further simplify or further reduce the wastage of the addresses by dividing to the nearest possible size. For each and every requirement will be a different, even though you have a different requirements, we can still divide them in variable sizes. So that's what we do in the VLSM. So when it comes to calculation, the calculation goes exactly the same way, the way we do in case of FLSM, it's going to be the same. So here my requirement is 100. I think I'm taking 40, 20 and 10. So I want to divide a network in variable sizes with this different requirements here. So let us start with the first requirement here. The requirement is 100 hosts. So I'm going to start with the higher requirement, 100 hosts. So I'm going to calculate the same way, 2 to the power of h minus 2 greater than or equal to requirement. And my requirement is 100. So what is the nearest value satisfies my condition? So you should be very good by this time. Probably the nearest value which satisfies my condition is 2 to the power of 7. It's 128. Exact 100 is not possible, so it's going to be 2 to the power of 7. And then minus 2 for network ID and the broadcast ID. So it will be 128 minus 2. That is 126 is my valid host addresses. So valid host addresses. Okay, so from this I can understand that which class I'm using. I'm going to use C class here. We'll do VLSM with B class and A class also. So right now I'm going to use a C class example. So by default, C class contains 3 network portions. That's what we know already because we already did that. And C class contains 1 host portion, 1, 2, 3, 4, 5, 6, 7, 8. And out of these bits, 8 host bits, I need how many? I just need only 7. So remaining 1 gets converted. So it will be 8 plus 8 plus 8 plus 1. So the subnet mask will be 255.255.255.128. So we already did some exercises on this slash value to subnet mask conversions. So up to here the calculation is same as we discussed, as we learned. It's going to be the same here. So now the next thing is writing the range is different here. So let me just come down a little bit to write the range here. So the range always written based on to the power of h value. So right now the h value is how much? H value is to the power of 7. It's 128 is the size of the network. So in the C class, the first 3 portions remains the same: 192.168.1, 192.168.1, and 192.168.1, and 192.168.1. So the first 3 portions remains the same. So I'm not going to disturb anything for the first 3 portions. Only the last portion varies depending upon the size of the network. Okay. So right now let me write down the first range. So the first range is to the power of 7, 128, which means my address starts from 0, and the next range will be 128, that is group of 128 addresses. Let me write down here plus 128 just for your understanding how many addresses I'm using here, and the range ends on 127. And what is the subnet mask? What is the subnet mask we got here? What is the slash value we got here? Slash 25. 8 plus 8 plus 8 plus 1 slash 25. So I'll write down the slash value here because mostly in the documentations you will see the range will be written like this. Now this is your first range. It starts from 192.168.1.0 and ends on 192.168.1.127, and the slash value is 25. And the size of this network is 128 is the size of the network. And the next range starts from 128, and the next size also depends upon the next requirement. So in case of FLSM, we just go ahead and do plus 128, plus 128, plus 128. That is what FLSM, where we divide in equal sizes. All the networks will be of equal size. All the networks are of equal sizes. But in case of VLSM, the next size varies depends upon the next requirement. So let's go ahead and try to see the next requirement here. So my next requirement is 40. So let me just start up with the requirement of 40 hosts. And what is the nearest power value satisfies my condition? To the power of 6. So it's 64 minus 2. So which means 62 is my valid host for subnet. And I'm talking about which class it is. It's a C class, so it will be network, and 1, 2, 3, 4, 5, 6, 7, 8. By default, there are 3 network portions and 1 host portion. So out of 8 host bits, I just need only 6, which means the remaining 2 gets converted. So it becomes 8 plus 8 plus 8 plus 2. So the subnet mask will be 255, 255, 255, 192. And what's the slash value? Slash value is how much? Total network bits. 8 3 is 24, 24 plus 2, 26. Now the calculation up to here it's going to be the same just like we did in the FLSM, but when it comes to the range always written based on to the power of h value. Right now the size of the network, what is my requirement? How much? 64 is the size. So which means now what I'm doing is whatever the addresses are divided, here you can see 0 to 127, I'm going to allocate the addresses 0 to 127 with slash value of 25 for this department. Let's say the branch office A, branch office B, branch office C, and branch office D. And I have addresses available from 128. So I'm going to provide the addresses from 128 and group of 64 addresses, which means plus 64 here. So the next size will be 192 and my range ends on 191. And what is the slash value? Slash value is slash 26. If you remember, we calculated. and the next network size, that is from 128 to 191, which is not exact 128, it is a size of 64, which is not same as the previous size. I'm going to allocate for the next department or the next branch. What is that? If you come down here, so I'm going to allocate 0 to 127 is already given, so I'm going to give 128 to 191 with a slash value of 26. I'm going to allocate in this branch office. Done. Okay, so the next requirement, so coming back to the next requirement, now the next range will be based on the next requirement. So we are given this address range already, 0 to 127 for some branch office A, I think so, and this is for branch office C. Now the next requirement is how much? Again, for the next requirement we have to calculate in the same way. So the requirement is how much? 20 to the power of 5 satisfies my condition, minus 2, 32 minus 2, so 30 is your valid host per subnet. And in C class by default there are 3 network portions and 1 host portion, and I just need only 5 bits, which means the remaining 3 gets converted. So it will be 8 plus 8 plus 8 plus 3, so subnet mask will be 255, 255, 255, 224, and the slash value is 27. So when you're writing the range always written based on the 2 to the power of h value. So the size of the network which I require is 32, so which means group of 32 addresses here. So it becomes how much? 224, and my range ends on 223. So from 192 to 223 with a slash value of 27, and this is the size of the network. So the address starting from 192 to 223 is a group of 32 addresses with a subnet mask of /27. Okay, so that's how we do VLSM. Similar way, the next requirement is just 10. So I'm going to go with the next requirement here. Requirement is just 10 bits. So the nearest value satisfies 2 to the power of 4 is 16 minus 2. 14 is your valid host per subnet, and then network host 1 2 3 4 5 6 7 8. So host bits I require how many? Just 4. So it will be 4 gets converted. It becomes 8 plus 8 plus 8 plus 4. So the subnet mask will be 255, 255, 255, 240, and the slash value is 28. And if you come down to write the range, and here 192 to 223 is already given. I think I have to allocate here 192 to 223. I'm going to allocate for this branch. It's a slash value of /27. So I'm going to allocate 224 to 239 with a slash value of 28. Anyway, I'll write the range over there because group of 16 addresses. So the next requirement is how much? It's just 16 addresses. 2 to the power of 4, 16 is the size of the network. So 224 to 239 will be a group of 16 addresses with a slash value of 28. So this is my next network with a group of 16 addresses. My requirement is just 10, but exact 10 is not possible. So still I have addresses available from 240. So I think I can use it if I have one more requirement of 16, let's say. I can use from 240 to 255 with a slash value of 28 and 28. Or you can have a requirement of 2 networks with 8, something like that. Okay. So if you just try to observe here, the size of each network is different. Like here it is 128, here it is 64, it may be 32 here, and here it is 16, here it is 16. Now whatever the C class network I have used, now the C class network, what I have used, let me draw it here, take some space here. So whatever the C class network I have, it's further divided into some multiple sizes, where I divided one network with a 0 to 127, I allocated here, and then I divided 128 to 191, which is a 64 addresses. So which means here actually I have used, this is the size of 128, and then this is the size of 64, and then again I got one more size of 64, and that size of 64 we are further dividing into 2 parts, 192 to 223, that is one size I have used here. and then again I got 32 addresses. In that I am divided into 16, 16 again. So if you see the C class network, we are not using the exact same sizes everywhere. It may be same, it may not be same, it vary. Now this is what we call as VLSM. Now in VLSM, the network size varies, and when it comes to production networks, in designing or implementations, we use VLSM because each and every branch or each and every requirement will never be the same all the time. Okay, you will definitely have some variable requirements. So whenever you have these variable requirements, we generally go with VLSM kind of examples. So probably in my next video, I'm going to explain you the same example, but I'm going to use some shortcut methods where it will be more easy for you to follow up. But again, for that, we need to have some strong step-by-step calculation process. You should have a very good understanding to follow that step-by-step shortcut methods. So that's something I'm going to explain you in my next video.